Okay, welcome to my talk about Kotlin EE. I waited a little bit for some people because I think it was a room next to us. It took a little bit more time. So I tried to finish still in time, so I maybe hurry a little bit, and if I'm too fast, please raise your hands and stop me. Okay, my name is Fihlon. This is my Twitter handle here, and I'm happy to be here and have a second talk. On my agenda, I have a few points, only a few points. First, a short introduction about myself. Then I start with some information about why I like Kotlin, why I like Java EE, and what Kotlin EE is. Because Kotlin EE is not a project like Java EE or Jakarta EE. I just invented the term to show that it's easy to use Kotlin together with Java EE library. And the biggest part will be some live coding, so I do not only want to talk about theoretical stuff, I want to show it to you live on my notebook. I work for a huge company in Switzerland, and huge companies usually have huge disclaimers like this one. The short version is, if you repeat what I show you today and you delete the internet or whatever happens, it's not our fault. Okay, short version. I am a software engineer. I'm working for a CSS insurance company. I work for a lot of open source projects. I'm working as an agile coach. So I'm teaching two teams in our company. I'm a part-time lecturer, 1 day a week. I'm teaching at a technical college in Switzerland. And I'm speaking like today at conferences to train my English. Hope you understand everything. Otherwise, just ask. And I'm writing articles and books. My first book in English will be available soon. And I'm a community leader. I'm organizing the monthly hackathon in Lucerne, where we contribute to open source projects. I'm a member of the board of the Java User Group Switzerland and Kotlin Swiss User Group. And I'm in the committee of selecting the talks for the Vox Days Zurich and Basel 1. Vox Days Zurich, no? Yeah. He's the organizer of the Vox Days Zurich here, Frederico. Okay, this is my book. Will, I hope, be available in the third quarter this year. It's about Kotlin web development for writing full-stack web applications with Kotlin and React. By the way, all the slides will be available to download. So at the end, the last slide, there's a QR code and there's a link. So if you take a picture there, you can download everything. I started this talk with a Buzzword Bingo. I do not like buzzwords. When I meet people and I tell them I work on a big monolith, they look at me and they, oh no, you need the money, right? And so I said, monoliths are bad by default today if you talk to people, but that's not every time true. And often they tell you all the problems you have, you can solve them. Use microservices. All your problems are solved. Okay, then you start doing microservices, and when you start doing microservices, you have different types of problems. When you then talk to some people, they tell you, well, yeah, microservices, start doing nanoservices. Until today, I have absolutely no idea what the difference is between microservices, nanoservices, all such stuff. And of course, if you talk to people about modern software development, in every third sentence, it's about Docker, just because it's cool. Well, it is. I show you why. And if I tell the people that I'm working with Java EE, that's even more bad. I say, oh no, that's such an old and heavy framework, it's so bloated, applications are so huge, need a long time to start, and oh my god. But that has not to be the case. Often it is the case if you do not know how to use it in a very efficient manner. Okay, why Kotlin? In my opinion, Kotlin is a very pragmatic language. It's statically typed, it's object-oriented, it's compatible to Java. You can use any Java library available. And if you know Java, it's very easy to learn. There are only a few differences. using or writing Kotlin feels natural after a few days. And of course, a very nice thing is it does not only compile to Java 8 bytecode, it can compile to Java 6 bytecode, even when you are using inside of Kotlin lambda, streams, and whatever. So you can use a modern language with lambdas and streams and compile to Java 6 bytecode and run it on an outdated application server if you have one in your company. Often huge companies do not update every version of the application server, so maybe you're a little bit behind. And another nice thing, which is relatively new, it's compilation to JavaScript. Usually we call it transpilation. So it translates the Java bytecode, the Kotlin code to JavaScript. So you can write client applications in Kotlin too. And you can compile to native code. So you have one language which compiles to Java bytecode, to JavaScript, and to native code. To Mac applications, Windows, Linux, even to iOS applications. And another interesting fact is if you compile to native, it uses the LLVM compiler stack, where you can compile to Webpack. So you can run compiled code inside your browser. But in my opinion, the biggest positive point for Kotlin is it's not invented by people who invented languages. It was invented by people who designed tools. So the tooling support is very good. Often you have a new language and it needs time for all the tooling to support these languages. In Kotlin it was at the same time. So you have very good support, of course, in IntelliJ, the Android toolkit, Eclipse, command line, everything works. If you look at Kotlin, the syntax is comparable to Java. This is the main function, as you can see here. The first difference is that you start with fun, because it's fun to develop functions with Kotlin. And you do not need a class around it. So if you write a main function, you just write a main function. You do not need to wrap it in a class. And the second obvious thing is here, we have the type. The type is behind the name of the variable, or in this case, the name of the parameter. So first the name of the parameter, then a colon, then the type. And if you look at the next row, it looks a little bit similar to Java 10, which was released this week. But here we do not have var, we have val, event equals, and then a string. The compiler looks, oh, that's a string, so he knows event is of type string. It is statically typed, even if you do not write string there. And val means it's a value. A value is immutable. We cannot change it. So we cannot reassign something to event. If we write there var keyword for variable, then we can reassign some other string to event. On the last line here is a print line. For print line, we do not need to import it like in Java. Java you can do a static import, or you have to write all the stuff down. System out print line. Here it's just available. And as you can see, you have the template string. And inside of the template string, you can just use your variables. Use a $, and you are done. If you want to print out the $, just escape it. Okay, that's basic Kotlin syntax. Oh, by the way, you recognize there's no semicolon. You can write a semicolon, it will work, but usually your IDE will tell you it's not necessary, please remove it. So you can write semicolon, you do not need to. If you try to create classes, it's comparable to Java. Here's a class keyword, then the name of the class, and if you want to write properties for the class, in Java we would write, for example, a private string name, etc. Then we will write a getter, setter, whatever. Here we just provide the properties inside of the constructor on class definition. This will automatically create getters.
Sorry, I saw this code yesterday as well. How do you do multiple? Like, for instance, if you want to initialize a person just with a name and an age without a company, if you want to do like separate.
You can specify multiple constructors.
Oh.
You can even specify constructors with optional arguments.
Okay. Thank you.
And here it will create only getters. It will create no setters because we specify the properties as val for value. If you would use var for some of the properties, it will create a setter for us. And when you look there, you have this strange question mark here. Kotlin is null safe. It checks all the null possibilities at compile time. So it is, at every time it's sure and safe that the name is never null. Never. Same with the age. But here with the company, well, not everyone works at a company, so company may be null. And to tell Kotlin the company can be null, you have to provide this exclamation mark there. So that means name and age cannot be null, company can be null. And if you want to access company later, you are forced to do a null check. It's all proven at compile time. A very huge difference to Java is if you write in Java a class, you can extend that class. Everyone can extend that class. And if you do not want anyone to extend that class, you make that class final. We call this open by default. In Kotlin, it's the other way around. In Kotlin is closed by default. So you cannot extend a Kotlin class. If you want to allow someone to extend a class, you have to specify the open keyword. In this case, open class person. Now everyone can extend that class. This is very important later for Java EE, we will see it. And, very nice, we have data classes. Very cool feature. Here I write data class person with the same as you could see before, with name, age, company, and that could be null. And it automatically creates a constructor for me, like with a standard class. So I can use the constructor here and provide the data. And the data class will have, of course, getters for it. It will generate a toString method for me. So if I just print line the variable, it will print this here, the name of the class, and in parentheses the values. So I have a very nice readable toString method. Of course, he will implement equals and hash code as well, automatically by the compiler. And another very nice feature of data classes is I can copy data classes. I can create copies. It's similar to cloning, but different because it really creates a copy of it. And if I call copy, I can optionally provide arguments and specify which value should be changed in the copy. So in this example, I have one value with name, age, and company is null, and the second one where name and age was copied and company was set to the specified value. So the copy function is a really nice feature. You can even use it from Java.
Is this a deep copy?
No, it's not a deep copy. Okay, you can have default values. There's only a small difference here. You can specify default values, for example here, in the constructor. And if you do this, you do not have to specify that value. Then it's enough to specify this too. But you can specify the third one. Yes?
So by combining the two, going back to my question, if we initialize Marcus as a person with Marcus in 24 without providing the null as the third argument,
yes,
in the previous code I would get an error.
In the previous code you will get an error. In this code, not.
Thank you.
So you do not have to write all these constructors on your own. Just specify your properties and say which properties are optional and specify default values for them. That even works for parameters, and you can use named parameters. So in the example before, I have my name and my age. My age. And here I have the same, but with named parameters. If you use named parameters, It's, you can use any order you like. You're not forced to a specific order. And if you have, for example, a constructor, or if you have a method you are calling, which has several int parameters, or several string parameters, or whatever, then sometimes it's hard to read. Because then you need to know, oh, what was the third int in that method call. So you can optionally use named parameters, and you know at every time in your code which parameter means what. Yeah. You have seen string templates in my first example. To string templates, it's important to know that you can call or access properties. So for example, to output the name, I can use $marcus.name and $marcus.age, and it will produce something like this. And sometimes if you have, here, it's easy for the compiler to know where the variable and the property ends, because here is a space. But sometimes you are putting something together with no space and adding more points, but the point should be printed. So then it's not sure for the compiler where the name of the variable or the name of the property ends. Then you can put them in these curly braces. And if I would do this here, it would here just use a print line, and here just normally print out .name like this. But it's very useful if the compiler is not able to do it on his own, and you have to help him. Then we have, of course, multiline strings. So if you put something together like HTML or whatever, you can use 3 quotation marks to start and end multiline strings. And you can even use string templates inside of multiline strings. And you should align it here at the first row. If you do not, you will have some space. But of course, there's a command that helps you to trim the leading space and prevents other spaces. You have singletons. Singletons in the language. You have not to build the singletons on your own. In Java, you create some instance variable. If you create the object, you have to log, to synchronize, etc. And here you do not need it. You just write object person controller, not class person controller. And if you say object, it is a singleton. And Kotlin makes sure that there's only one instance. And when there is only one instance, it does not make sense to call some get instance or whatever method. So you use a singleton like a class with static methods. For example, here I have a save method, and I just call personController.save. Person controller with a big P. It's a singleton. So the instance is available under the class name. Makes it much easier. This is everything you need. No more synchronization or whatever. A very nice feature of Kotlin's coroutines. They are pretty old. I think about 20 years or more, 30. Coroutines are not threads. If you work with parallelization, and you often work with threads to parallelize your work, and if you do this, well, a thread is very expensive to spawn. And with coroutines, you can work in parallel, but not necessarily with threads. So you can spawn, for example, 100,000 coroutines. If you will do this with threads, your computer will die. But you can absolutely spawn 100,000 coroutines or 1,000,000, doesn't matter. It works a little bit like Node.js. Who of you knows Node.js? Hands up, please. Ever done with Node.js? Not so many. Well, in Node.js, you have only one thread. You have some kind of, it seems that everything happens in parallel, but you have only one thread. It's the same with coroutines. They share the threads. So they are very lightweight, and therefore they are very fast. And they are easy to use. I just use the async keyword, and I can specify a thread pool here. And here I create a list of 10 price services, and I call price service price, the price method, 10 times, on 10 different prices, asynchronously. And later on, I can use on the list the sum by method. I can provide a lambda. Lambdas in Kotlin are written in curly braces, where I just say it.await. In this number, I do not have to specify a variable name. If I do not specify a variable name, like in Java, I have a default variable name it. I could write, for example, a job, then the, the arrow, and then job.wait, well, await. But I do not have to. If I do not provide the variable name, I have it. Okay, that's about coroutines. You can very easily create builders with Kotlin. There are already a lot of builders, for example, the HTML builder, like this. So you can create an HTML page in Kotlin using the keywords here. And the good thing is it's compile time safe. If you misspell title, it will not compile. So everything is checked as at compile time is your type safe builders. That's why they are type safe. Yes?
Does it recognize the new components in there?
No. It's very, very simple. Yes. And you can create your own type safe builders. For example, if you want to create SQL type safe builders, I think there is one available, or other stuff. Please do so. Okay. That should be enough about Kotlin for the first part. Now I want to talk a little bit about Java EE and why I think today Java EE is a really cool microservice framework. I'm gonna set microservice. With Java EE, I say it's something like library management as a service. Before I was using Java EE in other projects, I often had problems with the class path held. You had a library to your project, for example, let's say Guava. You had another library to your project that has a dependency on its own to Java, a transitive dependency, and at that time you have 2 different versions maybe of Java on your class path, or 3 or 4 different versions of Java. And then you can have crazy things happen depending on which Java wins at runtime. So you have to keep track of it, and you have to make sure that you have only one version of that library, of every library in your class path. You can do this with your build tool, with includes, excludes, and so on. But it's hard. Sometimes it's hard. And with if you focus on Java EE, you have only one dependency, only the JAX Java EE dependency. I said even if it's called Jakarta EE, it's still valid. And this is only the API. And the vendors of the application servers, they have to fulfill the API and ship all needed libraries. For example, they ship, how it's called here, JAX-RS and so on and all such stuff. But they have to take care of the dependency held, of the class path held, and look that there's only the correct version in the class path. So you do not have to take care of it. So one dependency. With Kotlin we need a second dependency for Kotlin standard library, but that should be everything we need today. And it's ready to use containers. That means that every vendor of application server provides ready containers for Docker. Even IBM in the meantime provides containers with Open Liberty and all such stuff. You have Whitefly, Payara, Glassfish, and so on. So you can rely on these containers, and your own container usually have 2 lines of code. You say, okay, I want to use the Payara micro, and I just copy my var file into the deployment directory, and you are done. You do not have to take care of installing Java in the container, installing application server, start up scripts, and so on. It's done by the application server window. And then if you look at the layers of your image, you have your application, then you have the application server, Java runtime, operating system. Usually there are much more layers between them. That's very simplified. But the important thing is that the application is on top and it should be as small as possible. So only your var file, no other dependencies. And that's important because you change your application a lot. If you are maybe 50 people in your team and each one commits 3, 4, 5 times a day, you have a lot of builds. And if you create images, huge images on every build, the build server spends a lot of time doing this. And so it's important to make sure that your application, which changes on every build, has its own layer, and all the other stuff which changes frequently, not so often, has their secret layers. And if you add more dependencies to your project, own dependencies, please create a secret layer for that. Because, for example, if you use frameworks or whatever for your project, they usually do not change 10 times a day, but your application may change 10 times a day. So please create a secret layer. And another nice feature is it's a standard. So if I'm not satisfied with my application server, with the vendor, or maybe updates are coming slowly, or there's an annoying bug which is not fixed fast enough, or whatever, I can choose between different types of application servers. And this is only a selection. There are much, much more. And most of them are open source or have open source possibilities. Okay, what do I mean by Kotlin EE? Kotlin EE, you won't find it on the internet anywhere. It's just a creation. I put together Kotlin and Java EE. And then you have some issues if you want to use Kotlin together with Java EE, because classes are final by default. And application servers want to extend your classes. They want to create proxies. And you can mark your classes as open. But if you do so, everyone is allowed to extend your class. And if someone is allowed to extend your class, someone will do it. So it would be cool if it can stay final, but for the application server it looks like an open class. And therefore we have a plugin for the compiler. And this makes sure that all classes which have these annotations here are made open at compile time. So your IDE looks at the source code and sees, oh, the class is closed, nobody can extend it. And at compile time, it makes these classes open, so that at runtime, your application server can extend them and create proxies. And that's a very nice feature, so your teammates are still not able to extend your classes. Same with constructors. If you have a class with resources, we will create one later. It needs a zero-argument constructor. And if you create a zero-argument constructor, anybody will use it. Same story and same fix. There's a plugin for it, a no-one plugin, and just configure it and specify, for example, annotations. And at compile time, it will make sure that the class with these annotations has a zero-argument constructor. These are the two biggest issues from Kotlin to use with Java EE, and call them solved. Okay, enough slides for the first moment. Let's do some live coding and see how it works all together. Live coding is always very risky. I hope internet will work, I hope my compiler will work, everything will work. If not, you can just laugh, or maybe you can shout a solution to me. And let me show first what I would like to create with you. I would like to write two services. One is a hello service. It's very stupid. You call it and it just answers with hello and your name. But to make it a little bit more complicated, it should talk to another service to see how one service talks to another service. In this case, the time service. So the hello service asks the time service for the time. Of course, you could do it on its own, just for demo. And then the answer back to the user contains hello, the name of the user, the time, and I add the host name to see the scaling later, because I want to scale on 3 hosts so that we can see in the output that the answer is coming from different hosts. The hello service will be available from the outside, the time service not, only from the inside. So, yeah. And of course you can do this what I show you today with Kotlin and Java EE, you can do with Java, Scala, Groovy, any VM language. Okay. Next, you. So that we do not have to wait too long, I prepared something. I use Docker for my presentations and for all this container stuff. And I want to create a Docker cloud with 3 nodes. And Docker can do this on its own. You can tell Docker, please, create a machine. There, Docker machine create. Use the driver virtual box and name the node MGR, that's a name. And that means Docker machine will use the VirtualBox driver, which talks to VirtualBox in the background. It will create an instance of a virtual machine. It will install the operating system, the networking stuff, SSH, the keys, and all the Docker stuff for me. And I have to do nothing, just wait a few minutes. And I can use different drivers. I can use drivers for Google Cloud Engine, for Amazon, for DigitalOcean, whatever. And if I use other drivers for the services in the internet, of course I have to specify my credentials. And then Docker will create the running instance on Amazon. It will install the operating system, networking, SSH keys, everything for me. Absolutely seamlessly, I have to do nothing. And that's quite nice. Okay, so I created 1 node with the name MGR. And then I created 3 nodes with the name node 0, 1, 2, and 3. So I have 4 nodes now. And you can log in to the manager. There will be a manager and worker nodes. The difference is, on the manager you execute every command. The manager manages this, the whole cloud is managed by the manager. Never connect to a node to start some services or whatever. Okay, then you log into the manager. Then you initialize Swarm. Swarm is a Docker internal cloud. You say initialize, then you specify the external address. And this will create a cloud. Now we have a cloud running 1 node. And then there's a nice tool. It's called Visualizer. This is a Docker run command to execute it. It's a Docker container. I already started it, and if I open it in the browser, over here, this is what it looks like. A little bit smaller. Of course, at first, only this one here. You have only 1 node. It's a really nice tool to visualize all your nodes. Then you can join all the other nodes you created. I created the manager and I created 3 more nodes. I want to connect them all together in 1 cloud. So you can ask the manager for a join token. That's for authentication against the cloud. He tells you the token, then you log in to the node, and then you paste the command. The command means docker swarm join, -- token, then the token here, and the public address of the manager. You just paste it there. The complete command is written to you on the console if you ask the manager. You just paste it, press enter, and done. Your node will connect the manager, authenticate to the manager, and be part of the swarm, independently of where your node is. It can be on Google, Amazon, wherever. Okay, you can verify everything. There are commands to list the nodes. Docker node ls for list, Docker info for some detailed infos, IP addresses if you like. Yeah. And you have, then you end up in this view. So we have one manager and 3 nodes together in one swarm. Okay, before we now can create or run our services, we have to write them. Is it correct? I have only 15 minutes left. Okay. So I make a very short version here. I shall just switch. Let me see. Oh, done. I think it's better not to code everything now because I think I can't do it in 15 minutes. So I will walk through the code with you. At first, creating the time service. The time service has 2 classes. We use Java EE, and when we use Java EE, why it's not? Why? Okay, better restart IntelliJ. Maybe it was annoyed about changing the screen resolution.
Or you still run the chat box?
No, it stopped. It asked me to stop it. I did a 2-hour workshop just before, so that's why I sound a little bit strange. Okay, now it should work. View, oh yeah, presentation mode, wonderful. Okay, so if in this case I want to provide a RESTful API, and I want to use JAX-RS. JAX-RS is built into Java EE, so I do not need additional dependencies, but I have to configure it. And in this case, here, I have one class, because in JAX-RS I have to extend the application class on JAX-RS. And here you see extend is not done by the extends keywords, it's done by a colon. And there's no difference between a class you extend or an interface you implement. You just use a colon in Kotlin. Kotlin has annotations like Java, and JAX-RS needs to configure an application path. In this case, I name it API. That means that all the resources are prefixed in the URL with API. So it starts with HTTP, hostname, /API, /everything else. And that's everything you need to configure JAX-RS. And then I want to implement a resource. This is a time resource. Again, it's a class, extend nothing. It produces plain text. Well, it could produce anything, JSON, XML, whatever. In this case, just plain text. And the path is time. So the complete path is /API/time. And here I specify a function. I call it getTime. And the function returns a string. So the return type is specified at the end of the function declaration, not before. And with add_get, JAX-RS knows that this method will be called when a get call is done to the time resource. And the only thing I do here is local time now to string. And here you can see you can just use every Java class, Java API, Java framework, whatever, just use it. There's no special syntax or whatever. Just use the classes and call the functions. There's one difference, which I will show you on the second example. So what we have now is an answer to a GET request to /API/time, which will return the actual date and time. Then we need a Docker file, and as shown on the slides, 2 lines. You just say, please, from Payara Micro, which is provided by the Payara company, and copy the time service var file to the deployment storage. That's everything you need. The second service is the hello service. It has, again, it has to be configured. JAX-RS has to be configured. It's exactly the same, so there's absolutely no difference. But the resource itself is, of course, different. So, again, we have a class. We produce plain text. In this example, I put the path annotation here, hello. So we have /API/hello. And here we specify that when a GET request comes in, please execute this function. I call this function say hello. I want to extract a parameter from the request. So I use the path param annotation just from JAX-RS. So it will extract the parameter and provide it to me in my name variable, which is of type string. And I will return a string. That's a return type at the end. Okay, so, another new version of Kotlin. Not now, please. Okay, then I want to call the other service, because the hello service internally calls the time service. Therefore, I need the time service. And here I can use again JAX-RS. This means I create a value, so it's immutable time service of type web target. Here I have to specify the type because here it's some problems with the type inference. Then I just use a client builder from JAX-RS, say new client, and as a target time service 8080 API time. Okay, so I created the time service, a reference to the time service. And every time the say hello method is called, I use the time service, send a request, it's a GET request, and to come back, I expect a string class Java, crazy syntax. That's because in Kotlin we have a string class. In Java we have a string class. So now we have 2 string classes. But here, because here we are using JAX-RS, it wants to return a Java string class. And that's what you do here, that you just add a .java at the end. So, okay, not a Kotlin string class, a Java string class. For the host name, I just use init address get localhost hostname. And then I return a string saying hello name from the parameter, new line time from the time service, and the third line with the host name. And that's everything. And when we then take a look at the Docker file, it's the same as the other Docker file, only that we have hello service here. And that's everything we need to build. So, at first, let's do this, okay? Group, create a wrapper, assemble. Okay, and if you take a look, we can now use it directly, but we can create now the Docker image with Docker build. We tag it. My kernel is my username on Docker Hub, like my Twitter handle. And it's a time service. And the Docker file is located here in my example as a time service subfolder, subdirectory. Now we create the Docker image, done. The same with the hello image, or hello service, sorry. Hello service directory, and take it as hello service. Oops, yep. So, done. Now we compiled and created, we compiled 2 services, we created 2 images. And now my workflow. So, because the time service is not available from the outside, the hello service should. They should talk to each other. You have a very nice feature in your Docker swarm, it's called a network, an overlay network. You can create as many overlay networks as you like. And that's important. When we start our services, we give our services a name. Because if we run 3 instances of the time service on 3 different hosts, how can we find them? Docker will find them for us. So if we go back here to the hello service, we see that we use no host name. We use the name of the service. Docker has an integrated DNS. It knows where all the instances are running and it's searching for an instance for you and forwarding the call to this instance. And that it works, the time service and the hello service must run in the same network. Not on the same machine, the machines can be anywhere on the world, just in the same network. And we can create a network with the command docker network create driver overlay, for example box. Overlay means that it's on top of the real networks, and if you have a node running on Google, Cloud Engine, one on Amazon, one on your own machines, they are all together in one network. And every command is executed on the manager, so I have to connect to the manager. I do this by Docker machine SSH to the manager, and I'm there. I paste the command docker network create minus driver overlay voxed, and it's created. This is just a hash as a confirmation. I can do docker network ls, and here I see there is a new network, and it's available in the whole swarm. Now I can start my services. It's done this way. Docker service create. Please use the network voxed. And the name should be time service. The name will be used then for DNS. And please use the image macro time service we just created. Let's execute this. And while it loads the image and started it, let's look at the second service, because the second service should be available from outside, so we need a port mapping. So we use this, we'll copy this, paste it again, press enter. And if we take now a look at the visualizer, here it is. We will see one hello service and one time service. The green dot here means that they are up and running. And the color here around is a random color, and it's the same for the same service. You see the image tag and updated and so on, everything is there. Okay. We can see the same on the command line. So if you are on the manager, we can use docker service ls for list. Docker service ls for list. And we will have a list of our services. We see that it's replicated, and we see that we have one replica running of one. So we want one, we have one. Okay, let's test it. We can use curl or the browser or any other thing. I have a nice command line utility, it's called HTTP. So I make an HTTP request to HTTP. This is a public IP address of the master, called 8181/API/hello/workspace Bucharest. press enter. And this is the answer. It's okay, and as we can see here on the lower right corner, it extracted the name out of the URL. We have the actual time, and this is the host name. Host names on Docker are always hashes. Okay, works. Our service works. And our service, called the time service, and back works. Now, when we develop applications, today often we have some kind of scaling. And often it's difficult to test all these scaling features. We need a lot of servers to test all the scaling stuff. With the help of Docker and Docker Swarm and VirtualBox, we can do this locally. We can test all the scaling features locally on our computer. Therefore, we just say Docker service update replicas 3 hello service. That tells Docker, now I want 3 instances of the hello service. Execute the commands always on the master. Oh, that was my computer. Not very good. This is the master, as a manager. Okay? And now let's take a look here at the visualizer. And now we see we have 3 instances of the hello service running. And Docker was searching for nodes with capacity. So he is looking at all the hosts, how many containers are they running, how much memory do they have, and then it's starting the containers on nodes which have not so much to do. Let's do the same with the time service. Costs nothing. Time service. Whoop. Here they are. So it's pretty fast. The start-up of the application server inside the container is pretty fast. And now let's test it. HTTP call. And if you look at the host name, it starts with B21. This host name starts with 7A. This host name is D1. Again, B2, 7A, D1. You recognize something? We have automatic load balancing with what's called round robin, already built into the swarm. So you can test the scaling, how your database behaves, that you have no clashes, no synchronization issues with your application. So it's very cool. And from time to time, you need to take some of the nodes off to update the operating system or whatever. So you have to tell Docker that you want to take it off. And there is a drain command. So you say Docker node update availability drain manager. In this case, I want to drain the manager. Okay, let's go. As a manager, we have 1 container running. And we execute this command and switch back fast. The container was killed. No more containers on the manager. Now we have only 2 hello services, but we want 3. Docker recognizes it, then it looks around the hosts, and it will start a 3rd one soon. And there it is. So Docker always tries to fulfill our expectations, or our rules. We define that we want 3 replicas, and he takes care of it. And if you want the manager to be available again on the node after you do some stuff, then you can set it to active again. So that is the Docker part. In my opinion, this flow, using a pragmatic language, using easy API, small API, using things like Docker, makes you write very easy to understand code. You have fast build times because you have only a few lines of code. You do not build fat jars on every build, only small war files. With Docker, you have reproducible deployments. You have the same image you deploy on your local machine for testing, on your test servers, integration servers, production servers, and so on. And it's very easy to scale. not only in production, but on your testing machines or on your own machines too. So you can easily test all the scaling stuff on your own machine. Yeah. And in my opinion, you can be very fast using this stuff, so you can focus on your business code and you do not have to think too much about all the technical stuff around it. Because I earn my money with business code and not with doing technical hype stuff, so I need to focus really on creating business code. And the more business code I create, the less I have to spend on all the other stuff, the more I earn. Yeah, not really, the more I can do. Okay. Yeah, I'm nearly finished. I'm from Switzerland. Well, I'm born in Germany. I'm living in Switzerland for more than 10 years now. Maybe you dreamed of living in Switzerland because it's such a nice country. We have mountains, beautiful mountains, villages, and ships, and lakes. Lakes and mountains all together. This is from Lucerne, the city where I live. This too. And I show it to you because, well, living in Switzerland is not cheap. It's expensive. So you need to earn money. And if you want to earn money, please ask me. We are searching for people at every time. We are the biggest basic health insurance company. We have about, in the meantime, should be about 2,800 employees, 130 software developers full-time, so we have 24 Scrum teams. We are very agile. Please contact me. And of course, it's time for questions. And this is the QR code and the link where you can find the slides, the example code, everything. And yeah, if you have questions, please come to me. And oh, before I forget it, I'm from Switzerland. We are famous not only for cheese, but for chocolate. So I have for everyone here Swiss chocolate and Swiss sweets. Please take something. Questions? Yes, the chocolate is sweet. Okay, you can contact me at any time, maybe later. If you have any questions, please contact me on Twitter or drop me an email or whatever. Yeah. And enjoy the conference.